What you know about rolling down in the deep?
Assalamualaikum and hi everyone. My name is Nurhaja binti Syamsulizam and the topic of the journal to be discussed is performance assessment of an internal combustion engine at varying state temperature. And I will give you a brief introduction of this topic. In this study, the main focus will be the effect of varying deep state temperature on SCG efficiency of a high oleic methyl ester HOME fuel internal combustion engine ICE by using the SCG analysis method to identify the losses and efficiencies of the various types of engine. And for the information, this analysis method is based on the second law of thermodynamics. Based on this paper, SCG efficiency values at various state temperature are calculated for comparison purpose since fuel internal combustion engine ICE with 4-stroke has been used in this experiment to conduct the experiment. Based on this result, it found that SCG efficiency values range between 29.78% to 39.92% based on this state temperature between -5 degrees Celsius and 30 degrees Celsius. Next, you must be wondering what is the SCG and what is the internal combustion engine ICE. Okay, firstly, I will explain about the SCG. SCG is a potential or quality of energy, and usually SCG always evaluated by the environment reference, which is a deep state. And you must be wondering how deep state can be achieved. Deep state can be achieved if the thermodynamic system is in equilibrium with the environment. For example, above explain about the SCG that illustrated by the potato figure. The temperature of immediate surrounding changes from that of hot potato to environment, which is a system delivers the maximum possible work as it undergoes a reversible process from the specified initial state to the state of its environment, that is the deep state. Next, I will explain about the internal combustion engine, which is the combustion of a fuel occurs with an oxidizer in a combustion chambers that is an integral part of the working fluid flow circuit. Next, the working principle of the internal combustion engine is either gas law, which is when the temperature of gas is rising, then the pressure will also increases. That makes the gas want to expand. Next, this figure shows how the internal combustion engine work using 4-stroke. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Shaidan. My metric number is B04191022 and I'm from section 1. So in this video, I would like to discuss about the schematic diagram in this case study, which is performance assessment of an internal combustion engine at varying state temperature. So the study purpose is to investigate the effect of varying state temperature on SCG efficiency of high oleic methyl ester fuel internal combustion engine. Before we go to the schematic diagram, I would like to give a little introduction about the engine used in this case study. So as we can see here, this is a two picture of John Deere 4045T diesel engine. This engine is created by Deere and Company, which is John Deere as the founder. So this engine has 4-stroke, 4-cylinder, turbocharged, and have 66.5 kilowatt maximum power capacity. And John Deere 4045T diesel engine run with HOME, which is genetically modified with a high oleic soybean oil methyl ester. So this is the schematic layout of the exhaust emission test unit. So the result of the combustion residue from the engine will go through exhaust emission testing. The combustion residue will flow to the exhaust and flow to three-way, which is one to analyze the CO2, CO, and oxygen, and then another one is to analyze the HC and nobelium, and the last will flow to the smoke meter. So this is a schematic layout of the engine test unit. At the middle is the diesel engine, and also have a dynamometer to measure the mechanical force, power transmitted by the rotating shaft. And here we have the entrance of fuel, and here is the entrance of air, and here is the entrance of water, and this is the exhaust manifold temperature, and also the measurement device of emission. And every part of the entrance element have a flow rate control to measure the measurement device of the flow rate, and also the measurement for temperature. And at the entrance of the water has a heat exchanger.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Akhtar Maida. So now I will proceed for the explanation of the method of performance analysis of this current study. In this study, SAG analysis method was applied to a John Deere 40450 diesel engine fuel with high volumetric ester fuel at various state temperature. Some properties of the fuel are illustrated in the table. K-type thermocouples were used in all the temperatures measurements. In engine emission test, carbon balance of the system was used for the asymptotic analysis. These devices were calibrated on each testee, and the sensitivity of them was less than 0.2%, while carbon balance was 92%. It means that the uncertainty of the emission bench is less than 8%. High-oleic soybeans were obtained from the Soybean Biotechnology Program of the University of Nebraska-Lincoln, USA. Conventional soybeans were acquired from a commercial supplier in Ames, IA, USA. The oil from soybean was extracted, and the methyl ester soybeans oils were produced in the biodiesel pilot plant, which was part of the Iowa Energy Center's Biomass Energy Convention Center, Nevada, USA. Results of exhaust emission values were required. The engine test was done, and schematic layout of the engine test unit is indicated in the figure. That's all for me. Thank you.
Hi, my name is Amir Hakim bin Kasib. Now I'm going to explain to you about performance calculation of the system regarding to our general citation, which is assessment of internal combustion engine at varying dead state temperature. First, we have to know the equation of steady state open of thermodynamic system. If we can see at the above side, the first is mass in is equal to mass out, and second is SAG loss plus network of the control volume. Next, the network of the control volume is calculated with the experimental data. Based on the figure, we are able to calculate the value of frequency by given of the data of RPM. And next, we are able to calculate the value of the network of a control volume by substitute the value of frequency, and the result we get is 51.95 kilowatt. Second is the energy input rate of control volume is found using a lower heating value, HU, and a mass flow rate and fuel of the fuel. So this figure show how the analysis is performed, and based on the equation, we are able to get the value of heating fuel is 134.169 kilowatt. Next, heat loss of the control volume are evaluated as a difference between the energy input rate and network by using this equation above. By using this equation above, we are able to solve the heat loss of the control volume, and the value that we get after substitute the value of E dot fuel minus work net is 82.21 kilowatt. Energy balance of a control volume is written as a figure show, where energy heat is a energy transfer of a rate associated with heat transfer at temperature T. Energy W is a energy work rate, M dot is a mass flow rate, E is a specific flow SAG, and SAG destroy is SAG destruction irreversibility rate. Next, the net SAG work rate is equal to a net energy work rate. So by using this equation, we only use the data from a network of the control volume, which is 51.95 kilowatt. We are going to calculate the input SAG rates. As shown in this figure, the input SAG rate is equal to mass flow rate of fuel times specific flow fuel, which we are being get the value is 128.18 kilowatt. Next, we are going to calculate the chemical SAG factor. The effect of sulfur was included in the correlation for biodiesel fuel. So by using this equation and from the data from the table, we only substitute the value of H over C, O over C, and alpha over C inside the equation, and we able to get the value of chemical SAG factor, which is in 1.0735. Next, we are going to calculate the exhaust SAG rates. Based on the figure, we can see the table show the thermodynamic characteristic of a product at a various dead state temperature. By using the data on this table, we are able to use this data of H and S to get the value of exhaust SAG rates. Finally, after we calculate all the data, we are able to get the value of exergetic efficiency. By using this figure, we are able to use this equation to get the exergetic efficiency. After we substitute all the data, we are able to get the exergetic efficiency of 40.53%. Next, this figure show the result of exergetic efficiency at various state temperature. This graph show the temperature from -5 to 30 degrees Celsius. That's all from me.
Assalamualaikum. Hello, my name is Nuradia. This is the final segment of the video. I'd like to go through the purpose of our presentation again. This study is to determine how different dead state temperatures affect the exergetic efficiency of an internal combustion engine powered by high oleic methyl ester (HOME) HOME. This engine is a John Deere 4045T diesel engine with a 66.5 kilowatt maximum power output and home, which is genetically designed with a high oleic soybean oil methyl ester. It was discovered that as the dead state temperature dropped, exergetic efficiency rose. Exergetic efficiency values decline when reference dead state temperatures climb. According to the findings, at various dead state temperatures, the rate of exhaust energy altered. At the very dead state temperatures, heat transmission also reduces. We may discover the restrict factors in IC's effectiveness. During the cooling of the engine, heat is lost. Exhaust gas heat losses are a concern. Expenses incurred as a result of incomplete, insufficient combustion. Carbon dioxide and water will be produced if perfect combustion occurred. So, what should we do? Variable injection timing. This is the terminology is already used in maritime engines. The injection is advanced at low loads and speeds, allowing the same mean effective pressure to be maintained. This is not only improves the engine efficiency by maintaining the scavenging pressure, but it also allows for the use of lower quality fuel. Variable valve timing is a feature that allows you to control when the valves open and close. The opening and shutting time of the exhaust and inlet valves can be changed in this way, impacting the efficiency. The efficiency of this procedure can be increased by 4 to 5%. Twin spark plugs and multiple injectors. As the flame front moves outward from the spark plug, some fuel is left unburned because it is ejected before the flame front reaches it. Using the proper viscosity of lubricating oil, as viscous oil might cause friction losses. That's all from me, Noradia. I'm from group Deadpool. Thanks for watching.